You know that feeling, right? Yeah. You're staring at your computer screen. You need to do something that feels like it should be simple, but
Hmm.
you're clicking around, wrestling with menus, different windows, and it just feels like you and the computer are speaking, I don't know, different languages, even with graphical interfaces.
Oh, absolutely. GUIs, graphical interfaces, they were a huge leap, no doubt. But the sheer complexity of modern software, even they can feel pretty overwhelming when you have a specific task, especially one that involves multiple steps.
Exactly. So imagine if you could just, well, tell your computer what you need done,
Yeah.
in plain English, and it could actually understand you, look at your screen, see what you see, and then do the things, manipulate the stuff on screen like you would.
Yeah, and that's moving beyond just understanding text, isn't it? That's about interacting with the visual world on the display.
It really is.
And that's this fascinating evolution we're seeing. We started with large language models, LLMs that get text. Then came visual large language models, VLMs, which can also perceive images like, say, a screenshot of your desktop. And the next step really is large action models, or LAMs. These translate that understanding, both text and visual, into actual concrete actions on a device, interacting with the interface itself.
Okay, and that brings us to our source material for this deep dive. It looks closely at a specific project applying these, well, pretty cutting-edge ideas directly to the Windows operating system. It's called UFO.
Right, UFO. And it stands for something quite technical, unified framework for automating operations, I think. Definitely not the flying saucer kind.
Ah, yeah. Although, honestly, some of the things they can reportedly do sound almost futuristic.
They kind of do. So this deep dive, what we want to do is unpack the key ideas behind UFO. Like, why focus on Windows? It's a big platform. How is UFO actually built to, see the screen and then act across different apps? What are its special features, especially for Windows? And importantly, what did the tests in the source material actually show? What can it do now? And where are the edges, the limitations?
Got it. So our mission is basically to give you the essential insights into this, well, pioneering work.
Exactly.
Okay, so let's start with that why. Why Windows? We hear a lot about AI agents for maybe phones or web stuff, but Windows,
Yeah.
it feels like this huge, almost untouched area for this kind of tech. Why is tackling Windows such a significant thing, and what's the gap UFO is trying to fill here?
That's a really good question because you're right. While VLMs are emerging and we see UI automation efforts, most have really focused on, say, smartphone interfaces or
Yeah.
maybe simpler web apps. Windows is a different beast altogether, more complex.
Just because it's,
Big.
well, because it's Windows. It's on
Yeah,
like most desktops, does almost everything.
that's definitely part of it. It's massive market share, it's ubiquity in day-to-day computing, but critically, it's also the sheer variety and depth of applications built for Windows. Many have incredibly rich, sometimes really complex GUIs. And think about the kind of tasks we do on Windows. Often they're quite involved, right? Multi-step workflows that mean jumping between different applications.
Right, like pulling data from one place, maybe putting it into a spreadsheet, then writing an email about it.
Yeah,
That's classic Windows use.
exactly. That's where a lot of the friction is for us humans, switching context, copy pasting, all that. And the sources really position UFO as, well, one of the first agents designed specifically to handle these general tasks across this really varied and demanding Windows app landscape. It's trying to address that specific gap.
Okay, so it's tackling the inherent complexity of Windows head on.
Yeah.
How does it actually do it? How does UFO manage to, see everything on your screen, maybe even across multiple monitors, and then figure out what to click or type?
Well, at its core, like we said, it uses VLMs to interpret the visual information, the pixels on the screen, kind of like how we look at it. But the really clever part, according to the source, is its structure. It's built with a two-agent system. There's a host agent and an app agent.
Ah, okay. Like maybe a manager and a specialist worker. Does that analogy fit?
That's actually a pretty good way to think about it. The host agent is the high-level planner, the strategist. It takes your request, your instruction in natural language, and it looks at the entire desktop. It gets screenshots, potentially stitched together from multiple monitors. It knows which apps are running. And crucially, it keeps track of the overall plan and its own memory of what's been done so far.
So it has the big picture view, the context of the whole task.
Precisely. Its main role is to understand your goal, break it down into a high-level plan, decide which application is needed for the next step, and sort of monitor the overall progress. It's formulating that global strategy.
Okay, makes sense. And the app agent then, the specialist.
Exactly. The app agent is the executor, the one that gets things done within a specific application window. Once the host agent says, okay, we need to use Word now, The app agent takes over for that part. It focuses really intensely on that specific application window. It gets detailed screenshots, not just a clean image, but often annotated ones showing where all the interactive controls are. Buttons, text boxes, menus, you name it. It also receives structured information about these controls, their
So
properties.
that zooms right in, gets really granular to detail, but just for that one active window.
Yes, it dives deep into the UI elements of that particular app. Its job is to figure out the precise sequence of actions needed right there. Which button to click, what text to type into which field, maybe selecting a specific menu item, all the low-level interactions within that app to achieve the current sub-goal.
Huh. That dual structure actually sounds really logical for handling Windows complexity. You've got one agent managing the overall flow, navigating between apps, keeping the goal in mind, and the other one focusing intently on just getting the specific steps done correctly within whatever app is currently active.
It really allows the system to break down these potentially very complex multi-app tasks into more manageable chunks. It handles both the high-level thinking and the detailed low-level execution.
Now, the sources also made a point of highlighting some specific features, things designed to make UFO work better on Windows and, maybe more importantly, safer to use.
Oh.
What were those special sauce elements they talked about?
Yeah, those are really key design choices that make it more practical. First up is interactive mode. UFO isn't designed as just a, fire and forget tool. You can actually communicate with it while it's working on a task.
Oh, really? Like you can chat with it mid-task?
Sort of, yeah. You can ask it to maybe refine a step or clarify something, or even step in yourself if it gets stuck on something it can't handle, like the classic example is maybe a cappy TCH, or perhaps entering a password which it shouldn't know. This makes it much more flexible for real-world scenarios where things don't always go perfectly smoothly, allows for user guidance.
So it's less like just issuing a command, more like collaborating with an assistant.
That's a good way to put it, yeah. Then there's action customization. This one's pretty powerful. Users can actually define their own custom operations. You can teach UFO new tricks, basically. If there's a specific workflow or a series of actions you do often in a particular app, and UFO doesn't know it out of the box, you can provide descriptions and examples to add it to its repertoire.
Wow, okay. That makes it sound incredibly adaptable.
Yeah.
You can tailor it to your specific needs over time.
It makes it highly extensible, yes. Then there's control filtering. This tackles a big practical problem with Windows UIs. They can be incredibly busy, right? Sometimes hundreds of buttons, labels, icons, all visible at once.
Oh yeah, cluttered screens are definitely a thing.
So UFO uses smart filtering techniques. It has like a hard filter based on the type of control that might be relevant, and then a dynamic soft filter to focus its attention even more narrowly when needed. It helps it zero in on the likely interactive elements it needs for the current step.
It's like giving it tunnel vision almost.
Mm.
So it only really sees the buttons or text boxes that are probably relevant right now, cutting through all that visual noise.
Exactly. The sources suggest this significantly boosts its ability to correctly identify and interact with the intended control, especially on those busy, complex screens. Better accuracy, better performance. And finally, maybe the most critical one for practical use, the safeguard.
Yes, the safety net.
Right, because computers, they handle sensitive information, they can perform irreversible actions. UFO is specifically designed to identify certain types of operations as potentially sensitive.
Like what kind of things?
Things like sending emails or messages, deleting files, closing windows that might have unsaved changes, accessing hardware like your webcam or microphone, installing software, or trying to retrieve stored passwords, things you really want to be sure about.
Okay, yeah. Pausing before it, say, deletes a folder or sends an email to your boss, seems like a very good idea.
Essential, really, for building trust, right? So before UFO executes any of these predefined sensitive actions, it must get explicit confirmation from you, the user. It pops up a request, explains what it's about to do, and waits for your okay. Ensures you're always in the loop for these potentially significant actions.
That makes a lot of sense. So they built this system with these features. How did they test it? What could it actually do in practice based on the source material?
Well, the evaluation described involves setting it 50 different tasks. These tasks spanned across 9 common, widely used Windows applications, things like Office apps, browsers, code editors, and they were designed to cover a pretty diverse range of typical daily computing activities, not just trivial stuff.
And the sources went into quite a bit of detail on one really complex example, didn't they? The one involving composing an email using info from different places.
Yes. That's a great case study they highlighted because it really shows off UFO's potential for handling those multi-app workflows we talked about. The task was something along the lines of go into a Word document, find specific action items mentioned in the text, then open an image file, get a description of what's in the image, and then combine both the action items and the image description into a new email draft in Outlook, ready to be sent for review.
Well, okay, that definitely involves reading, extracting info, describing something visual, remembering it all, switching apps multiple times, and then composing intelligently. How did UFO actually handle that sequence?
It followed a plan orchestrated by the host agent. So first, the host agent would direct the app agent to open Word. The app agent would then interact with Word, maybe using an API call like getText mentioned in the source, to pull out the relevant action items. And crucially, that extracted text gets stored in UFO's memory.
Right, it holds on to it.
Then, the host agent decides the next step is the image. It directs the system to switch to, say, the Photos app. The agent then observes the image displayed in Photos and generates a textual description of it. That description also gets stored in memory.
Okay, got it. Word text, image description, both now in memory.
Exactly. Then the host agent orchestrates the switch to Outlook. The app agent takes over within Outlook. It starts composing a new email. And here's the clever bit. It intelligently retrieves the stored action items from memory and the image description from memory, integrating them into the email body. And finally, just before actually hitting send, because sending email is a sensitive action,
The safeguard kicks in.
the safeguard prompts the user, I'm about to send this email with this content, is that okay? And waits for confirmation.
That whole sequence really demonstrates that ability to maintain context across applications, to remember information, transfer it, and use it purposefully. It's definitely more than just like recording and playing back mouse clicks.
Absolutely. It showcases that multi-application planning and the information integration capability quite effectively. The sources also mention some other interesting examples of tasks it could handle.
Oh yeah, like what?
Things like efficiently deleting all the speaker notes from a large PowerPoint presentation, or reading a PDF document, summarizing its content, and even using OCR to describe figures or diagrams within the PDF. Or even designing a PowerPoint slide applying different designer formats, but also, interestingly, providing a textual explanation for why it chose a particular aesthetic.
Wait, explaining its design choice.
Yeah.
That hints at some level of reasoning about its own actions, doesn't it?
It certainly suggests that, yeah, a bit more than just following rote instructions. And the evaluation also compared performance using different underlying models, specifically GPT-4 versus GPT 3.5.
And how did that shake out?
They noted that GPT-4 generally performed significantly better within the UFO framework. It achieved higher success rates across the board, especially, it seemed, on more challenging applications or ones with less standard interfaces, like maybe VS Code or the Edge browser. GPT 3.5 apparently struggled more often with things like initial navigation or finding the right controls in those trickier UIs.
Okay, so the power and sophistication of the underlying VLM or LLM that's driving UFO still makes a big difference in how well it ultimately performs.
Definitely seems to be a key factor, yes.
So given all this capability, where does it currently fall short? What do the sources say about the limitations of UFO right now?
They were quite upfront about that. A primary limitation at the moment is its dependence on the UI controls and actions that are exposed by the specific backend technologies they used for interaction, things like Pywanado and the Windows UI automation framework. If an application uses highly custom controls, or maybe it's built with a technology that doesn't play nicely with those frameworks,
Then UFO might struggle to interact with it properly.
it might not be able to see or manipulate the controls in that application correctly, yes. So it's not guaranteed to work flawlessly with every single piece of Windows software out there right now.
Right, that makes sense. It depends on how the app itself was built.
Exactly.
Yeah.
But they do explicitly mention this as an area for future work. They plan to try and expand support, maybe by incorporating alternative interaction backends, or perhaps even developing dedicated visual models that could potentially interact with GUIs without needing that structured control information, which could make it much more broadly compatible.
And do they touch on any other future directions? I think you mentioned something about multi-agent systems earlier.
Yes, briefly. They alluded to the concept of multi-agent LLM frameworks, thinkers like AutoGen, MetaGPT, those sorts of ideas. The idea there is that instead of one monolithic agent trying to do everything, you might have multiple AI agents collaborating, Each could specialize in a different part of a task or a different type of interaction. This is often seen as a potentially more scalable approach for tackling even more complex, really multifaceted tasks in the future. It sort of builds on the spirit of UFO's dual agent structure, but potentially takes it much further.
Huh. So maybe a future where you have a whole team of little specialized AIs working together behind the scenes to get your complex computer tasks done.
It certainly points in that kind of direction as a way to handle increasing complexity. Yeah.
Okay, let's try and wrap this up then. If you had to distill the main takeaway from this deep dive into the UFO project, what would it be?
I think the key insight, really, is that UFO represents a significant, concrete step towards creating a truly general-purpose intelligent agent, one that can operate effectively across the incredibly diverse and complex Windows ecosystem just using natural language. It's about moving from AI that just understands language or sees images to one that actively does things within the applications you use every day. It bridges that gap between understanding and action in a major desktop environment.
And it tackles this using that clever hostage and app agent structure for planning and execution, combined with those really practical features like the interactive mode for guidance, the ability to customize its actions, the smart filtering to handle visual clutter, and that crucial safeguard for sensitive operations.
Exactly. It's a system designed with the specific challenges of Windows in mind, aiming for an autonomous experience that feels, well, hopefully flexible, powerful, and also trustworthy.
Right, so here's maybe a final thought for you to chew on after hearing all this. Imagine if interacting with your computer genuinely felt as natural as just talking to a really skilled assistant, an assistant who could see your screen, understand exactly what you needed to get done, and just make it happen smoothly across whatever applications were needed. What kind of new possibilities does that open up? How might it change the way we approach automating all those tedious multi-step digital tasks that, let's be honest, many of us still wrestle with today?